Good afternoon, students. So now in today's class, we have to discuss with that cluster analysis. Already in the last class, we have to completed what is the cluster analysis and what are the clusterings, what are the different types of clusterings and the cluster types. These are the concepts you have to complete in last class. So here the grouping of data points presented as simply you can call it as cluster. So here in clusterings, you have the different types of clusterings you have to use. Those are we have to discuss different types of clusterings we have to use. Those are hierarchical clustering versus partitional clustering, or exclusive versus overlapping versus busy class clustering, complete versus partial clustering. So these are all concepts you have to complete it. And the next one is the different types of clusters you have to use. Those clusters are, one is the well separated clusters, prototype based clusters, and the center based clusters, graph based clusters, contiguity based clusters, density based clusters. So here shared property clusters. So these are the different types of clusters you have to use in cluster analysis. So whenever you have to using this cluster analysis, first one you have to using some algorithms regarding to this K means algorithm. Mainly you have to use in cluster analysis. So once how we can discuss with that. So first one, these are all basics of the clusters. Well separated clusters, center based clusters, continuous clusters, density based clusters, property or conceptual clusters, described by the objective functions. So these are the different types of clusters. So now we have to discuss with that. First one is the well separated clusters. So first the clusters you have to represent it as separately. You have to represent the clusters, that is the red, green, and blue. So separate clusters, that is the well separated clusters. So next one is the center based cluster. Center based means you have to represent the four center based clusters. You have to represent it with the medoid. You have to represent or centroid. These are the center based clusters. Next, continuous clusters, nearest neighbor. Nearest neighbor, for example, here one data point you have to represented here, and a nearest data point, but compared to the its center, other cluster center is near. So that is the continuous nearest neighborhood. You have to present it as a transitive. A cluster is a set of points such that a point is in a cluster is closer to one or more other points in the cluster than to any point not in the cluster. That type of cluster is simply called as continuous cluster. So here you have to represent the continuous clusters of each. Next one is the density-based clusters. In the density-based clusters, mainly a cluster is a dense region point of points which is separated by the low density regions from other regions are high density. Used when the clusters are irregular or intertwined, and when the noise and outliers are present. That you have to represent it as density-based clusters. And the last one is the shared property clusters or conceptual clusters. Here we have to overlapping the clusters. That type of clusters are called shared property clusters or conceptual clusters. So here clusters depend by the objective function. The NP-hard problems mainly you have to represent it with these clusters, or minimize and maximize of objective functions. You can find the cluster. That type of clusters defined by the objective function. So generally here you have to use the objective function NP-hard. This is regarding to the different types of clusters. And what are the characteristics of input data you have taken? So here type of proximity of density or measure. Type of proximity or density measure you have to represent it as it's a derived measure for the simply you can say that it is a central to cluster. Dictates the type of similarity, adds to the efficiency. Attribute type dictates the type of similarity, type of data, dictates the type of similarity and the characteristics, dimensionality, noise, outliers. So outliers means it completely one particular data points are grouped together. That is called as cluster. So outside the cluster you have that type of data points are called that is outliers. See here what type of algorithm, clustering algorithms you have to use. Here three types of clustering algorithms you have to use. First one is the k-means algorithm, and its variant algorithm also there. Second one is the hierarchical clustering, and third one is the density-based clustering. First one is the k-means algorithm. First one, whenever you want to discuss with the k-means algorithm, it's a partitional clustering approach based on the center point. Each point is assigned to the cluster with the closest center point. So the number of clusters k must be specified. The basic algorithm is very simple. Select the k points as the initial centroids. K points as the initial centroids. Completely, we have to repeat it from the k clusters by assigning the all points to the closest centroid. Recompute the centroid of each cluster until the centroids does not change. For example, in the k-means clustering, in that k-means clustering algorithm, only you have the 5 steps. It's completely based on that centroid. So that is the center point based on this algorithm you have to implement. First one, how many points are there? The k points are there for the initial centroids. As the k points as the taken as the initial centroids. Now we have to repeat. That means from the center point, what are the points are there? So from the K clusters, repeat form K clusters by assigning all points to the closest centroid. So first centroid nunchi closest points we have to assign to the K cluster. We compute the centroid of each cluster until the centroid set does not change. మనకి చేంజ్ అవనంత చేంజ్ అవ్వకుండా ఉన్న వరకు you can repeat it again. So I will show the example here. Here you have to see this is the two different types of K-means testing. Initial centroid for the often chosen randomly. Clusters are produced vary from one run to another. The centroid is the mean of the points in the cluster. The closeness is measured by the Euclidean distance, cosine similarity, and correlation. K-means where they converge the common similarity measures mentioned above. For example, here you have to consider the complexity of this K-means algorithm is order of n into K into L into D. So n means number of points, K means number of clusters, L means number of iterations, D means number of atoms. So you can find out the complexity of the K-means algorithm. So by using this order of n into K into L into D. So by this is the complexity of K-means algorithm. Now you can K-means algorithm you have to apply. These are the original points. All are green. You have to represent it as original points, and red and blue. These are the original points. Now we have to apply the optimal clustering. Optimal clustering means, so here where the green points you have to represent it. So this is from the centroid. You can check it out. So nearest points. Here you have to check out all the data points. Where the nearest, those you have to represent it as one cluster. And here you have to compare the blue points are there. Those points you have to check from the centroid to the distance between the data point and the centroid. So which is the nearer, that only you have to consider. So these 2 points are, see here, actually in original points you have the green points. These 2 are the green points. But after optimal clustering, these green points you have to convert it into blue points. So that is which cluster is the nearest. That points we have to consider. That is the optimal cluster. Again, we have to suboptimal clustering. Suboptimal clustering is the nearest you have to represent. Entire one particular cluster you have to divide into suboptimal clusters. That is simply can represented as optimal and suboptimal clusterings. So here, this is the importance of choosing the initial centroids. So which one you want to centroid here? So first one, these points you have to centroid this point, and for the green points you have to represent it as this is the centroid, and for the blue points you have to represent it as the centroid. Now you have to find out the distance between from the centroid to that particular point. So you have to find out the distance, which one is the nearest, that only you have to represent it as one cluster. See here, that is iteration 1, iteration 2, iteration 3, iteration 4, and iteration 5, iteration 6. Finally, you can get these 2 blue points you have to get in. So actually in first you have to consider that only we have to getting the different types of points. But whenever you have to, after complete iteration, no data points you have to change it. That only these 2 are we have to change. So remaining all points you have to represent it as same cluster. So which data points are needed to the centroid, that only you have to consider. How to evaluating the k-means cluster by using the algorithm, sum of this squared error, that is SSC. This is a common measure for that SSC. For each point, the error is the distance to the nearest cluster to get SSC. We square these errors, but sum them. SSC equal to summation of 1 to k. X belongs to C of I. Distance square M of I comma X. X is the data point in cluster C of I, and M of I is the representative point for the cluster C1. Can show that M of I corresponds to the center of the cluster. Given two clusters, we can choose the one with the smallest error. One easy way to reduce the SSC is to increase the k, the number of clusters. A good clustering with a smaller k can have a lower SSC than a poor clustering with a higher k. So simply you can use the formula SSC, that is the sum of squared error equal to the summation of I equal to 1 to k with the x belongs to always the x belongs to C of I. Distance square of M of I comma x. So by using this formula, you can get the sum of the squared errors. X is the data point of the cluster, and C of I and M of I is the representative points for the cluster C of I. You can show that M of I corresponds to the center of the cluster. So this is the evaluating the k-means clusters. Here you have to implement the initial centroids. Importance of the choosing the initial centroids. You have to find iteration 1 up to iteration 5. So you have to getting problem with the selecting initial points. If there is a k real clusters, then the chance of selecting one centroid from each cluster is small. Chance is relatively small when the k is large. If clusters are small, same size n, then p equal to number of ways to select the one centroid from each cluster. The probability of that is the k factorial by k power k. That is simply you can say that number of ways to select one centroid from each cluster. The number of ways to select the k centroids. For example, the number of clusters is 10, so the probability 10 factorial by 10 power 10. That is, you have to getting the value 0.00036. That is the probability we have to represent it initial points. Probability we have to represent it here. Sometimes the initial centroids will adjust the numbers right away, and sometimes they don't. We have to represent it here. So see here example pair of clusters. These are the centroids for the each. You have the 10 clusters are there. In those 10 clusters, you have to represent it centroids for the each cluster. Starting with the two initial centroids in one cluster of each pair of clusters. You can represent it in it while you have to performing the iterations. So see these examples, iteration 1 and iteration 2, iteration 3 and iteration 4. How it works. So first one you have to represent it starting with the two initial centroids in one cluster for each pair of clusters. Starting with the sum pair of clusters with the three initial centroids, with the other have only one. So like this way you have to perform. Finally, which one is the nearest, that only we have to consider. Solution, if you have centroid or particular data point is let us assume that is the centroid. So how we can choose that centroid? That is the problem while you have to facing. While choosing the centroid, that problem you have to solve out by using the multiple runs helps that probability is not in your side. Sample and use the hierarchical clustering to determine initial centroids. Select more than k initial centroids and then select the among these initial centroids. Post-processing we have to perform, and it's bisecting the k-means algorithm also you can use. It is simply you can say that initialization issues you can handle with this bisecting k-means algorithm. This is the handling empty clusters. Basic k-means algorithm is simply you can say that is yield to empty clusters. Several strategies you have to use related to the SSC. Generally, here whenever you have to processing in the basic k-means algorithm, you can process two types. One is the pre-processing, second one is the post-processing. In the pre-processing, normalizing the data, eliminate the outliers. In the post-processing, eliminate the small clusters that may represent the outliers. Split the loose clusters, clusters with a relatively high SSC. Merge the clusters that are close and they have relatively too low SSC. And use these steps during the clustering process, ISO, ISO data. So just now in you have to discuss with that k-means algorithm. Now you have to discuss with that bisecting. Again, you have to divide. There is a bisecting k-means algorithm. In the bisecting k-means algorithm, you have the 8 steps, but whereas in a k-means algorithm, you have only 5 steps. But whereas here, you can represent the 8 steps. First one is the initialize the list of clusters to contain the cluster containing all data points. Okay, but whereas here, select k points as the initial centroids. You have to consider here. And repeat up to until you have to perform this number of times we have to iterate it in the k-means algorithm. But whereas here, initialize the list of clusters to contain the cluster containing all data points. Now you have to repeat it. So in the repeated and between the repeat and until you have the 5 steps are there. Those steps are, first one is selecting a cluster from the list of clusters. The particular list or particular cluster you have to select it, and for I equal to 1 to the number of iterations to bisect the selected cluster using basic k-means algorithm. And you have to consider all the clusters. So first one you have to consider the one cluster. In that cluster, we have to performing the number of iterations, bisecting the selected cluster using k-means algorithm. So after repeated, you can get the centroid, and after I add that, 2 clusters from the bisection with the lowest SSC. Lowest SSC. Sum of so see here you have to see this formula. See here, this is the sum of squared error. Sum of squared error equal to summation of I equal to 1 to k. This x belongs to C of I. Distance square of m of I comma x. By using this formula, you can find out like this. That is the add to 2 clusters from the bisection with the lowest sum of secure SSC to the list of clusters until the list of clusters containing k clusters. K-means has the problems that when the clusters are differing sizes, densities, non-globular shape. K-means has the problems when the data contains outliers. So that is the limitations of K-means algorithms. Limitations of K-means differing the sizes of original points with the K-means 3 clusters you have to represent it. So whenever you have to after applying the bisecting K-means, so here you can represent it like see here. This is the three. These are the original points. Again, we have to divide into these the data points. So this is one cluster. This is you have to represent another cluster. This is the another cluster. So I want to bisecting K-means algorithm. You have to apply it for these original points. That will be converted into K-means 3 clusters. So here you have to consider the particular data point. So that nearest data points you have to represent it here, and you have to represent it as this is the centroid. So nearest data points you have to represent it as another cluster, and here you have to represent the one centroid, and nearest data points you have to represent it as another cluster. You see here this is regarding to this simple bisecting K-means algorithm. Original points you have to apply it for the K-means. Here you have the density will be deferred. The limitations of K-means for non-globular shapes. Globular shapes, non-globular shapes. Overcoming the K-means limitations. These are the original points and the K-means clusters you have to apply. One solution is to use many clusters, find the parts of the cluster, but need put together. So overcome the K-means limitations, original points and K-means clusters. Next one is the hierarchical clustering. In the hierarchical clustering, two main types of hierarchical clustering is agglomerative and density. So now we have to discuss with that an hierarchical clustering, that is the agglomerative clustering. In agglomerative hierarchical clustering, this clustering is approach refers to a collection of closely related clustering techniques that produce a hierarchical clustering by starting with each point as a singleton cluster and then repeatedly merging the two closest clusters until a single or all encompassing cluster remains. Some of these techniques have the natural interpretation in terms of graph-based clustering, while others have an interpretation in terms of a prototype-based approach. This is the agglomerative hierarchical clustering. Next one is the last one is the DBSCAN. DBSCAN algorithm mainly you have to use the density-based clustering algorithm. Hierarchical clustering, density-based clustering. Density-based cluster algorithm is DBSCAN. A hierarchical clustering algorithm is the agglomerative hierarchical clustering. And K-means and bisecting K-means algorithm. So these are the four algorithms you have in this 4K. So external point of view, most of the examinations they have asked these are the algorithms. First one is the a priori algorithm, FP growth algorithm, K-means algorithm, or agglomerative hierarchical algorithm. That is the you have to represent it as agglomerative algorithm, and the last one is the DBSCAN. Strengths and weaknesses. K-means is a simple and can be used for the wide variety of different data types and quite efficient, even though multiple number of often. K-means is optimization problem. This is the original points. Three K-means clusters we have divided based on that centroid. K-means non-global clusters. Global clusters we have to represent it. Non-spherical shapes. So this is regarding to that K-means algorithm. The derivation of K-means algorithm minimize the SSC. The summation of I equal to K, which belongs to C of I. C of I minus X whole square. See here, this is the sum of six. Dendrogram will have to apply for this clustering algorithm. So next class we'll continue the agglomerative and DBSCAN. Thank you. If you have any doubts regarding to this one, please write on chat box. We'll, again, you have to repeat again. So if anyone is not submitted the assignment one, please submit it immediately, as well as second assignment also must be submitted within 1 or 2 days. So everyone submit the assignments through the Google Class. Okay. Thank you.